Alright, you guys, it's time to get real. Chapter 4.7 deals with the category of numbers called real numbers. And real numbers are just a set of numbers that includes the rational numbers that we're familiar with. Remember, numbers that can be written as fractions. That means terminating decimals, repeating decimals as well. But the real numbers also include a category called irrational numbers. We have rational numbers and we have irrational numbers. And the irrational numbers are decimals that don't terminate or repeat. And we've talked about an example of pi. Pi is an irrational number because they haven't found an end to it yet. The square root of 7, also an irrational number. It's a decimal that just keeps going and doesn't repeat. So, rational and irrational, that makes up the set of real numbers. Because believe it or not, there are numbers that are not real. Alright, so a basic type of problem is going to be just deciding if a number is rational or if it's irrational. So rational, fractions, repeating decimals, terminating decimals, integers, and irrational numbers are non-repeating and non-terminating decimals. So here we go. 2.5, that's rational. The square root of 24. Well, is 24 a perfect square? Nope. So square root of 24 is going to be irrational. Square root of 16, is 16 a perfect square? Yes. So its square root is an integer. It's rational. 7.7 repeating. Repeating decimals are rational. The square root of 4 over 9. Well, remember the square root of 4 over 9 can be rewritten as the square root of 4 over the square root of 9. Perfect square, rational number. Okay, we have a nice diagram here to help you get a visual picture of the real numbers. Real numbers are rational numbers and irrational numbers. So you've got what's involved in each of those categories. You may want to remember that integers include whole numbers. So don't forget that whole numbers are also rational numbers. And integers, remember that if you have the square root of a perfect square, that's going to result in an integer as well. So integers have those types of numbers within that category. Alright, here's another type of problem. Write all names that apply to each number. So is it rational? Is it irrational? Is it a repeating decimal? Okay, is it real? So let's see. Number 1, the negative 7/8. Well, that's a rational number. It's a number that can be written as a fraction. Rational. So it's rational, and it's also a real number. Because it's rational, it's also real. All right, number 2, the square root of 0.15. Well, 0.15 is not a perfect square, so this is going to be an irrational number. And all irrational numbers are also real numbers. So number 3, the square root of 18 over 2. Well, what's 18 over 2? That's 9, so the square root of 9. Perfect square. Alright, so a perfect square is going to be rational. Okay, and it's also an integer, isn't it? And it also happens to be a whole number. What is the square root of 9? We're thinking of 3, remember? So whole number, integer, rational number. Well, and it's also a real number. So notice when we're writing all names that apply, we want to think of, you got to really think of every category that this number could fit into. Alright, you go ahead and try 4, 5, and 6. Okay, this question's a little bit different. State if the number is rational, irrational, or if it's not even a real number. Okay, so the square root of 14, 14 is not a perfect square, so its square root is going to be a non-terminating decimal, so this one's going to be irrational. The square root of negative 16. Alright, is there a number that I can multiply by itself to get negative 16? Can I get a negative by multiplying two numbers together? You can't have that. Okay, because if the signs match, you're going to get a positive 16. And if the signs don't match, well, then that's not squaring the same number. So the square root of negative 16 is not real. Okay, 6.2 over 0. That doesn't even exist. You can't divide by 0. You can't divide something into 0 groups. That doesn't exist. So that one is also not real. And number 10, square root of 49. 49 is a perfect square, so a square root of that is an integer, and integers are rational numbers. Okay, so you have to look at each situation and decide what that value is going to be, and then categorize it. And I want you to go ahead and try the next 4 problems. All right, this says find a real number between each pair of numbers. So there's something called the density property that says that if you have 2 real numbers, you can always find another real number in between them. No matter what they are, there's always something in between them. So let's look at example 15. 7 3/5 and 7 4/5. Well, we don't need to consider the whole number 7, but we need something, what would be between 3/5 and 4/5. Well, there's several different strategies for trying to find something in between. One of them is you can find the average of the 2 numbers, which means you would add them together and divide by how many there are. In this case, we would divide by 2. So I could add them together and get 7/5, divide that by 2, copy, change, and flip, and you end up with 7/10. So 7/10 will be in between. It's the average, the middle, of 3/5 and 4/5. So one possible number that's in between is 7 and 7/10. All right. Another strategy is, let's look at number 16. Another strategy might be, let's represent them both as decimals and find a decimal that's in between. So here we have 6.45, and what is 13 halves as a decimal? Well, that's 6 1/2, or 6.5. You could also write that 6.50. Well, what's a number between 6.45 and 6.50? Well, it could be 6.455. It could be it could be 6.49. There's all kinds of possibilities. You just have to find one real number that's between each pair. So you can go ahead and try and find 17. Give me one real number that's between 7/8 and 9/10. Okay, I'm going to let you try these 3 on your own. I want you to see if you can come up with answers for these 3 problems. Think about everything you know about what a rational number is, and find me one that's in between those 2, the negative of square root of 4 and square root of 4. Any rational number in between there. Number 19, give an example of an irrational number that's less than 0. And number 20, give an example of a number that's not real.